Okay, perfect. Then it's okay.
Yes.
Great.
Yes. Hello there, welcome back. And we have an interesting discussion, according to me, for sure. I'm also looking at data science a lot, trying to learn. So transforming your career in data science. We have some amazing people. I met them earlier as well. I'm just waiting to, hear them out. Thank you so much. Samran is going to moderate the entire discussion today. And thank you, Samran, for being here. And then thank you, Mr. Pankaj, and thank you, Abhishek, and thank you, Shweta, as well. Over to you, Mr. Samran.
Hey, thanks, Santosh, and thank you everyone for joining this session. And thanks, Ajay, Jagrutri, Anumeya, actually, for inviting me. It kind of gave me an incentive to at least kind of wear some colorful formal clothes and also get a regular shave. Now the current parlance is COVID stubble, so I think we kind of did away with that at least. Uh, so I think an important question that we're going to try and address is, how what careers are in data science, and while there is always a serious note to it, the important things I've realized is that the moment people start making jokes about your career or any choices you make, you know that you're doing the right thing. When I was at IBM, people used to make a lot of fun of IBM, and we used to always say that that means that we are doing something good. And I'll kind of just give you a few examples of that just to lighten the mood. So IBM's obviously international business machines, but it used to also be called "It's better manually," or it used to be inferior but marketable. Or the other one was "I blame Microsoft." And of course, the most unkind of them was intense bowel movement. So, uh, so such is also the case with data science these days. A lot of interest. There is some ambiguity, and that's the reason we've kind of got an eminent panel of speakers who will kind of guide us through this. I'm not going to take the time to introduce them because it's all there on your screen. So I'm going to jump right to it with Pankaj. So Pankaj, I mean, since you've kind of seen an evolution of the industry, various technology, so how have you seen this whole area of data science evolving over the last maybe several years? And have you seen anything different happening maybe in the last 6 months?
Yeah, Samiran, thanks. And having had all these gray hair, you tend to sort of look at things in a more zoomed out fashion than you would if you were just straight out of college. So the way I, set this context from my vantage point is that the more things are changing faster, it is probably to zoom out even more to look at a longer time frame to look at what's going on versus sort of be very siloed and look at what's happening in the last 6 months to 1 year. So the way I have started to think about the whole career journey is that in the past we took a course or some education which lasted us a lifetime. My dad retired in the same industry. He would have probably retired in the same company if it hadn't closed down, right? I'm surely not doing that, and my daughters will definitely not be that. So I do think that the past, I describe it as an area of continuous improvement, slowly moving, an arithmetic growth area. I think the current and the future is geometric and a continuous reinvention. And given that the past was, I think, in my opinion, driven by a tool called Six Sigma, I happened to use that tool at one point in time because that was enough to drive that arithmetic growth. I think the geometric growth has to be driven by a Swiss knife, if I were to use that, and a bunch of different things. And that bunch of different things keep changing. And AI is a great important tool, but so is design thinking, so is robotics, so will be many other things which we haven't been, become a fad yet. So that's the way I look at the future and the career. And I would not look at AI and data science as the be all and end all and tell people, hey, make a career in that. I would say the career is all about making an impact, creating something and all of those things. So that purpose has to guide you. The tools could change.
Thanks, okay. Abhishek, maybe in this panel you probably represent the next generation. So,
Thanks.
do you have kind of a different perspective to this as opposed to what Pankaj and possibly I have?
No, I mean, of course, the perspective is the same that effectively everything has to drive towards some kind of a value creation. Uh, but I'm going one level down in terms of how data science careers have changed. If you look at it, when I started my career in 2005, it was mostly about increasing accuracy of a decision, which was a broad decision to be made. risk models, good deciles, good gains chart, and things like that. Today, I think the conversation has shifted to micro problems, extreme specialization, and the speed of problem solving has increased tremendously. So today there is algorithms that you can run out of the box. Today, it is very easy to clean data, to derive variables, and do things like that. So the speed of output from an AI team or a data science team has increased tremendously. Earlier, it was about finding friends. Now it is about finding the closest friends on a platform. Earlier, it was about just finding love. Now it's finding the right love on the platform. So data science has kind of stepped into solving the problem right at its core and take it to the last mile of problem solving. But of course, it comes with its own challenges. Today, it's also very confusing on what data science means compared to 10 years ago versus today. Earlier, it was very simple. Somebody who would run an algorithm loves data and has a knack of problem solving. Today, it is very specialized, whether you want a data engineer or you want a data scientist or you want a visualization engineer or you want an analyst or you want somebody who can liaise with business. And so it is becoming more and more difficult. And just a small example I'll share and then stop that. We were recruiting from Bombay campuses this year, and we went for two positions. One is engineers and one is data scientists. And there was almost 70 people. And we asked that, how many of you want to apply for a data scientist position? All 70 raised their hands. And then my next question was, how many of you have opened or installed R or Python on your machines? And 69 hands went down. So it's a sexy job, but it takes a lot of time to get into the groove of it, which I think currently is not there.
Thanks, Abhishek. So moving on to the next one and just staying on the theme of fun and jokes, is that I just came across a cartoon that shows a guy making a resume and some senior person standing behind him. So the guy asks him that, do you know SQL? So the guy writing the resume said, no, I don't have any knowledge of SQL. So he said, just write down no SQL as a skill. So, so I think that's the way we are working at this right now. So Abhishek, therefore, obviously from what you said is that the skill is obviously extremely scarce, or at least good skills are extremely scarce. So given that, how are you in your day job managing to fill your requirements, find the right people, build the supply pipeline of the required data scientists? And what's your approach been and what's your experience been?
So, I mean, we are in Bombay, and in Bombay, finding engineering data science talent is always difficult. I mean, Bangalore and Hyderabad are hubs for it. And one thing that you can do, I mean, we didn't do it, is go to Bangalore. That's the first step towards getting good talent. See, typically for an organization, you don't need more than 10 great data scientists, right? So you're not looking for masses. The trick that we followed is, I don't think if you break down the data science into its micro components, I think the algorithms is far down the order. What you want is creative thinking. So you want people who should be able to understand basic common sense about business, to apply maths to that problem. So ability to do problem solving and the ability to think in a structured way is the first big component I look for. And that's where my base increases now, because I can look at pretty much anyone who can think clearly and apply creative thinking. The second step is then, are they good at math? And then you just apply one more filter on it in terms of degree, etc. And then you're left with a set of people who are good thinkers, problem solvers, can apply math. And then it's just about training them on R or Python, which is a very easy thing to do. So the trick that we followed is, we brought people in, and that's where I think Shweta will add more value, definitely, because we hired from Grey Atom back in our days. So we looked at people who were new to this industry, but had the creative thinking process and the ability to use math as their tool. And once that happens, then I think the ramp up curve on understanding tools, languages, techniques is very easy. And today we have 7 good data scientists in our company, and I think that's enough. That has brought us to a point where we can, with a single office in Bombay, serve pan India for our services. So, and of course, Shweta will add more to it.
Thanks, Abhishek. So I think that kind of naturally moves to you, Shweta. So obviously, from what I heard from Abhishek, it obviously, there sounds like there are several filters and a certain number of skills. So what is kind of generally your advice for people who are looking to kind of start a career in data science, either out of people who are kind of out of college or just a few years out. And then there is this whole segment which is mid-career, people who kind of maybe 10, 12 years, maybe in technology, maybe in something else. And now they feel that, data science is the next hot thing. How do they make that shift? And I'll just ask one corollary question, is that is data science really restricted to technical people? Which means that is it again that you become an engineer or you do your MCA and then you become a data scientist? Or is it kind of a more open field right now? So that's kind of the general drift of the question. If you could please help.
Perfect. So yeah, I'll answer all of those in an order. So at Grey Atom, my role has enabled me to see several hundreds of transitions into careers in data science and across all the spectrums that we just mentioned. So I'll first start with some of the skills that we see have worked for people when they are transitioning into these roles across organizations and across the broad spectrum of data science roles, be it a data scientist, be it a machine learning engineer, be it an NLP specialist, across all of these various roles, what has worked for people. So number one thing I would say is, even before algorithms, even before techniques, is that understanding of business and the business problems. So whether the business is solving for a higher revenue or to lower the costs or faster go-to-market, what is it that the business needs? And then being able to identify that metric and then associate it with a data science metric, right? So, we can't directly start with a ready-made data set like the way people sometimes start learning data science by attempting Kaggle challenges. In real life, you're never going to get like a ready-made data set on a platter. You're going to go all the way from first understanding and defining a business problem, bringing that business problem into realms of data science, making it a data science problem, defining the metric, and then solving for it. So I think the number one skill needed is understanding of what is the business trying to solve for. The second thing I would say is, 80% of the companies are using applied data science. People are not building newer algorithms. Like, for example, Cure.ai, if we take that example, they are for sure building their own proprietary algorithms. But I think 80% of the company, they use off-the-shelf algorithms and apply them to their business use cases. So if you focus on, again, the business problems and algorithms will then follow. I think the key here is to understand what algorithm should be used in what context. The third thing is around the backgrounds that you mentioned. Is it mandatory for somebody to have a computer science degree and then get into data science? I feel that diverse backgrounds are definitely helping bring in newer perspectives. So let's say somebody is from anthropology and then they understand the customer mindset and customer behavior well. I think they add a lot more value also to a data science team. Having said that, love for tech and coding must be there. So you can teach yourself coding. It's not hard. Python, again, is like a great language to pick up, even if you've not learned programming before. I think learning to code is one of the most easiest pieces of the whole puzzle, I would say. But if you're able to connect back to the customer problem and then what's the business trying to solve for, that's the most important skill. People need to have breadth. So again, we've seen where people succeed is they have a good knowledge of the math, stat, algorithm, programming, business understanding. I think if you have good breadth and then identify a depth in the whole process. So let's say somebody identifies depth in natural language. So that's an area that they love and they want to pursue that further, then so be it. But you need to have one area of depth that differentiates definitely you from a lot of other people. The sweet spot, I would say, for people making a transition is between 2 to 5 years of experience, because at that point in your careers, you're still very much hands-on. Somebody who's gone about 10, 12 years and then wants to transition, it's still possible, but it's a little hard because they've gone to do, bigger things up the value chain. So it's just that much hard for somebody to come back and be hands-on. On the behavioral traits, I would say that commitment to be lifelong learners is something that's extremely important, because with data science, there's a new framework coming every day. There's a new library that will be out. So you can't be stuck at where you were even a month back. You have to continuously keep learning. And the second behavioral trait I would say is important is the ability to iterate things very fast and have that no sunken cost mindset, that it's possible that you will have to sometimes throw away entire solution that you build and start from scratch. So you need to have that courage to throw what you've built out of the window and start afresh, because that hypothesis just went wrong. So I think those are some of the behavioral traits.
So at least from the perspective of the audience, what you're at least saying is that the coding and the R Python learning is probably important, but if they have great subject matter expertise, whether it be even in economics, any liberal arts subjects, then they could still make that transition if they are bringing great subject matter expertise. So the coding is not the biggest problem. That can be easily taught, but subject matter expertise is important.
Absolutely. I think if somebody leans towards learning coding, that's fine. I mean, and having said that, I'm not saying that you be hands-off. You cannot be hands-off. You need to have knowledge of at least one programming language. But that's an easier piece.
Okay, great. So Pankaj, I think on this careers thing, I think when we spoke, you said you had a personal experience to kind of share in terms of, I think, advising your own daughter on career choices, and maybe if you kind of take us through that experience, it will probably be helpful for people who are. And has Pankaj gone over here?
I think we lost Pankaj.
Not a problem. I think we'll wait for him to rejoin. So maybe Abhishek or Shweta, in fact, maybe on to you since you've got. So there is a certain when these new professions start becoming popular, there is a certain romance and mystique around it, that data science, that's the cool thing. I'm a data scientist, kind of. I'm just like I'm a Formula One race car driver or something. I'm that cool guy. But I was just wondering, in your experience, are there any standard myths that you've kind of come across, or that people should be aware of? That that things like you find any problem can be solved with data science, and a corollary probably is that what should people be ready to find? There should be some hard realities that that every day you're not going to be finding the cure to cancer or something. So that there are some myths and realities. So maybe in your experience, you could just share that, and then we'll go from there.
Okay, I can go first. So I think, as you said, right, the fads and classical myths that people have on the data science side, the number one thing is a lot of businesses think that data science is like a magic wand that will solve probably anything. And what we forget is the key to doing data science right is the right kind of data, and you need to start thinking right from the point the data is being captured. So I'll give you an example of that. We were working with this one organization, and they were trying to analyze their marketing campaign data, and what we found out was there was this one answer in the entire survey that was repeated like unusual number of times. And we were wondering, why is that the case? And what we realized, honestly, was that was happening because it was the first option for somebody to enter, in the form. And sometimes things like that also introduce a bias. So now at this point, thinking that a fancy algorithm is going to solve my problem, that's definitely not the case. You have to think all the way back from the point where the data is getting captured and how was the bias introduced. So I think that's something that people forget, and they just start thinking that algorithms are going to be the solution to everything. The second thing is that people also feel that there are certain things which are cool, and by this I mean sometimes the organization and sometimes the folks themselves. So they would feel that if I apply deep learning to this problem, suddenly this whole project is going to look very cool. But again, what we advise to people is that use deep learning only when this problem cannot be solved by traditional methods. Otherwise you should not apply deep learning. It takes a huge amount of resources, and why incur that cost, right? So I think that's one fact. Another one that I constantly see is the amount of importance we give to data versus an algorithm. That's slightly lopsided. We always think algorithms are cooler and data is not. So I think that those are a few myths I have definitely seen doing the round.
No, absolutely. And I think the key takeaway again for me here is that, just like every other profession, data science, there is a 98% perspiration and that 5% inspiration. So you should not be going in thinking that, I mean, there are some cool things I'll do. You will need to do the groundwork. You will need to be ready for disappointment. You need to be, like you pointed out, do things iteratively. So, and that's when success will come. And it's like, I guess, discovering of the COVID vaccine. I mean, it's not going to happen overnight. You're not going to, it's going to take 18 months to do it. So, that's I guess the way it will go.
Yeah.
Okay, great. So I think Pankaj is still having some problems with his connection. So I think I'm going to jump to you, Abhishek. So I think, again, given your Reflexilo's experience and anything else, maybe you can give us some examples of data science gone well, and more importantly, anything that you are aware of where data science is really kind of made of hash of things. So obviously within the limits of confidentiality, but if you could just give some, of course the successes are always touted, but where have there been any big gaps of classical failures, and even if they're from quoted sources, I mean published sources, it's fine, because I think people would love to know.
Sure, Samiran. So for us, data science plays a very important role because, and just to kind of give you a one-liner on what we are trying to do, we are effectively trying to convert a 200-step borrowing process that happens today for a small business owner in the country, convert it to a completely digital, fully automated process. And you can imagine it has hundreds of human interactions. So many examples of success that we've seen. And while I agree with what Shweta was saying in terms of it's not a magic wand, but if there is anything close to magic, then that is it. So there is, if there is hope, that's a lot of it will come from AI in terms of complex problem solving. So today, when you talk about image processing, voice analysis, text analysis, these are the places where we've seen immense success and incremental shift in terms of our accuracy and cost and speed. So take very simple examples which everybody would understand, like a KYC. In order to do a KYC, today you have to essentially ensure that the borrower is at the place where they are supposed to be. They are the borrower who are receiving the money. The money is going into their bank account, and the shop that they claim to own exists, and it is running as we speak today. Now, in order to have that real-time verification, effectively a customer records a video standing outside their shop where they have to keep the frame focused on themselves and the shop name. Now, that's a simple 10-second video that they have to record, and they have to do it in real time, which means they have to record it on the go. And the algorithm then extracts the name of the shop, the location of the shop from a lat-long perspective. It identifies that the borrower is the same as what is on the PAN card or the Aadhaar card through face recognition. And then it applies techniques to find out if it's a video of a video or if it's a real video. And all of these are done in real time. Now, that's a very complex stitching of pieces from an algorithm's perspective, and it is all done real time. So there are definitely examples of where great innovation has happened on that front. Then there are, of course, risk. Today, we can find out through voice analysis, we can find out almost using voice as a lie detector. So typically when you and I speak, we have, you judge me in terms of my sincerity of the response by observing some tonalities, modalities, and so on. We are now able to extract those, isolate those signals and see whether that really means that the customer is aware about what they're answering and are confident about what they're answering. So you are trying to replicate these human interactions into a digital interaction, extraction of signal, and then use it for risk reduction. And I can take plenty of such examples where we've done such stuff. Also, one of the things that doesn't work well, I think in most of the data science problems is, I think the follow through is missing. So the first level of algorithms will come by very fast. It will solve 70% of the problem. But the long tail, the 30% needs a lot of follow through, constant challenging, etc. I think the data science as a career is in that phase where we are all specialists, but we're not solving the problem.
Okay.
Isolated examples there are there, but holistically, do you see a head of analytics or a head of data science going to a CEO position in the next 2 years? No, because typically, and I refer to a very good book that I recently read, which is Skin in the Game. It's a book by Nassim Taleb. It kind of talks about the fact that if you're recommending something, do you have skin in the game? Because if you don't have skin in the game, then what you're recommending is it could be academic. It has no practical value. And I think data science is still in that phase where it does not have a skin in the game. It is hiding behind details. It is hiding behind algorithms, but it's not far out in the open in the green field to say, okay, I'm going to play the game if nobody else is going to. And that's an important aspect that every data science career aspirant should remember.
I get that point, and I think that from that CEO perspective, I think you're right about skin in the game. Unless, of course, you become like J. Edgar Hoover and because of your insight, you start maintaining dirty files on everybody in the company, and you probably become CEO. So I think we're having a challenge with Pankaj. So maybe just quick 1 minute, we'll just go around on the last point. Is that that if from this conversation forward, if someone were to have some takeaways on the couple of things or 2 or 3 things they should do to advance their career in data science or take it to the next level, what are the few things you would suggest very, very quickly, and just kind of a minute each, so that then we can have a little time for Q&A and then wrap it up.
Pankaj is here, so maybe Pankaj, you
can start. Let's try with Pankaj first. So Pankaj, if you can hear us, and we can't. So I think let's just go ahead because we'll run out of time. If Pankaj comes on, we'll just kind of abruptly stop and just give him the floor.
Sure. Shweta, you want to go first?
Yeah, sure. So I think if somebody wants to now, after this session, take away something and start at least identifying if the career is right for them, I would say take a breadth first approach, learn a little bit about everything that we mentioned in the overall game. So, business problems. Firstly, wherever you're working, identify that there's a business problem that you feel passionate about, and identify if that business can be solved with some of the data science techniques, and then it's an iterative process, because then you'll have to know more about the techniques and, pick a few things up and just go very iteratively in terms of learning something, applying something, learning something, applying something. And I think a good way to start that is, honestly, a lot of people feel that the Coursera course by N2NG is the right place to start, and you will become a data scientist by doing it. I would say there's a Udacity course, very foundational basics of data science and machine learning kind of a course, where they point by point, they open up different techniques and different problems to which these techniques are applied to. So definitely check that course out. It's I think UD 120 is the course title. The third thing I would definitely recommend you guys to do is follow the blog by Cassie Kozikrov. So she is the chief decision scientist at Google, and the way she explains abstracts out the math first out of the whole data science process and explains everything in very fundamental, foundational way. I personally am a big admirer. So if you want to get like a lay of a land first, definitely go and check out that blog on Medium. It's I can ping her name on the chat, and you can definitely check it out. So yeah, those are my recommendations, Samiran.
Thanks, Shweta. Pankaj, if you can hear me, I think you're still on mute. We're just asking about. Yeah, you're audible. Just the 2 or 3 things people should be doing as a quick takeaway of this course, to advance their data science career. If you could kind of quickly give us a snapshot, and then I'll give Abhishek the floor and we'll move from there.
Yeah, this was 3 years ago when my daughter was getting into college, and by the way, she's out of the college now. So there's a longer this thing, but I created what I say the 5C framework to let her choose the right career. And the 5 C's really are, curiosity, compassion, conviction, creativity, and communication. And that is what I shared with her. There's a long derivation because she obviously didn't believe what I said, but there is a derivation of how to arrive this framework. But essentially, that's what I felt, that, as long as you are curious, compassionate, which means, aware of all the surroundings, and therefore that brings you the conviction on what you want to do, and then be creative, and then communicate about it, and that creates the feedback. So that's my 5Z framework for my daughter, which I think applies now to me, and I would say to everyone else.
Okay, thanks. Abhishek, quick one for you, and then we'll...
So, pretty much everything is covered. People who tend to get into data science should not try to get into data science because it's supposedly a high-paying job. It can really be a drag if you're not good at it. So don't try to join the workforce because of the hype around it. You must be curious, as Pankaj said. There's a lot riding on the fact that the ones who get really paid well, and because salary is an important component when making these decisions, are the ones who are really good at it. The average data scientist is not talked by in the media. It's only the exceptional ones that do. And learn coding, speak to people who have been in this field, and luckily it's one of those times where you can actually live the life of a data scientist without being a data scientist. You can download a problem statement, you can take a course, you can speak to friends. It's not like how would you have to kind of spend a day in a manufacturing unit to experience what a manufacturing job would be. So it's very easy to digitally experience the life of a data scientist. Take a problem, run through it, do an internship. I love internships, and typically these are times. So one last thing I would say, Samiran, is these are times when jobs will be difficult to come by. One is going through a little bit of a difficult phase. And I tell almost everyone that I know that your salary is directly proportional to the value you drive for the company. And the value you drive for the company is a cumulative experience value. It's not a point in time. What you learn over the years kind of translates into that cumulative value that you can drive for the company. And hence, it's important that you keep working. It does not matter whether you get paid less or more today. Do an internship. Work with someone who has a problem but does not have money to pay you today. Because that experience is going to add up to you becoming a great data scientist, because this field changes so quickly that if you spend a year doing nothing, waiting for the right job to come by, then you are far behind others who have done something. And so those are my inputs for people, especially in this current environment.
No, thanks a lot. And hopefully we'll have some time for questions. So I think just one quick point from me on all this, that so while the data science is actually obviously a very analytical science, but it is also a storytelling approach, which means that you should be able to interpret and tell your story in the correct way. So in fact, one of my senior colleagues that once told me that the most powerful analytics tool is actually PowerPoint. So because unless you can actually tell the story of what you have interpreted and found out, then all your analysis means nothing. So anyway, with that, I think we've kind of come to the full end of the panel discussion. We're happy to take any questions. Actually, I don't see any hands raised or anything on the chat, but Santosh, if you have any...
Yeah, we don't see any raise hands. If you want to do it, you can quickly do it right now, audio. Or maybe you can drop in your question quickly where we can address out here. I think any one of the panelists. Or else, meanwhile, I'll just quickly, I'm not able to get over the statement what was done by Abhishek, saying that, earlier it was, finding love. And then right now is finding the right love. I think the next generation would be, finding the real right love.
Yes, yeah. There could be fake ones, yes.
Sure then. So I think if there's no questions, okay, everyone. Thank you so much. So I think if you have questions, you can drop in still. You still have to. Okay, there's someone raising the hand right now. Okay, Ajay is coming back.
Someone has to ask a question, right? So that could be me. So what is the potential of number of jobs that can be created within, whether you say data science as a domain, or even if you look broadly within artificial intelligence, what is the number of jobs that could, because people keep talking about jobs that AI could take away, right? But there is another concept of looking at it like, what are the new age jobs that can be created because of technology getting evolved and right across the value chain, whether it is purely through research, whether it is business. So in different ways, what kind of potential does it have? Anyone can take.
Ajay, there is a lot of conjecture around jobs being taken away by AI. I mean, if you look at it, years ago, people used to type, and there was a job called typist. Then everybody types, and I don't think that job has gone away. Those people have moved to better things to do.
Yeah.
And broadly speaking, there's a bit of philosophy in it also. I have a theory around it that when AI steps in, the cost of goods or the cost of services go down. So, and hence, the need for me to earn what I'm earning today goes down because I can get cheaper stuff out there. I'm taking a shortcut. There's a broad theory around it. And then, of course, there are people. So now, as an individual, I can spend 50% of my time doing other things that I want to do and not work because my cost of living has gone down because AI has brought that down. So if you look at it from an economic principle, I don't think jobs also will be a bad thing as long as everyone is 50% less paid. I mean, I'm talking about an extreme scenario. That everybody is paid less, but everybody is happier because they're able to do things that they were not able to do earlier. So there's just a philosophical angle around it. And then, of course, there's a practical angle that nothing changes tomorrow. So in our lifetime, I don't think we'll see robots going out and doing our work. But there will be certain aspects of our mundane things that will be taken away by AI. And it will result into cost benefits, which we will only reap. So I think nobody has to worry about that point of singularity or
So I think there's
I would like to add. Sorry.
So I think there's a book that Karim Lakhani, he's a Harvard professor, and he's written a book called Competing in the Age of AI. And in that he says that AI will change I will not take away every job, but it will change every job. So I think that's the philosophy here, that how we will be working in the future will change, but it's not necessary that every job will go away. Sorry, Shweta, please.
Yeah, so I just want to add one thing here. So I feel that AI more than anything is an enabler, and we start using so many AI tools as well in order for us to do our work better. I'll give a very quick example here. So there's this one tool that I have personally started using quite a bit. It's called Otter.ai, OTTER.ai. And what that does is, while I'm doing all my meetings, it's a natural language generation tool. It captures, it converts speech to text, and then summarizes all that I'm doing in a meeting very well, so that at the end of it, when I have to send out an MON, I don't need to type it from scratch. I just pick it up from there and put it. So it's not taking my job away. It's not replacing anything. I think AI is more than anything creating things where there were a gap and there was a problem to be solved, and AI is enabling us there quite a bit. So yeah, that's how I look at it.
I think one additional one that I would add, and on the lines like Abhishek said, that every technology allows you to do existing jobs better, allows you to go to new customers, and also allows you to create new needs for existing customers. So it's a classical, marketing theory, and gets applied all the time over and over again. So this time it's no different.
Thanks.
Cool.
So thank you so much, everyone. I think with this, we're going to come for a wrap. I think Dhruv, Dhruv's question is already answered, if I'm not wrong, by Samiran, right? Or do you want to put up a little more light on that one? Here's a question. That's an interesting one for me as well. How valuable is data science and coding for individuals working in other fields?
Oh, I mean, this is kind of the reverse question, that whether other people coming into data science, this is like coding being useful to people in other sciences. So I think my 2 cents, and other people can contribute, is that I think technology is going to permeate every area of work that you're in. So awareness of technology as a fundamental is like going to become a prerequisite. Now we want to take that a couple of notches further and develop some deeper knowledge of coding or algorithms and stuff like that. I think it is going to only be helpful, because I think your productivity and effectiveness in your chosen profession is going to also be determined by how technology proficient you are. I think that's going to be a certainty, and I'm happy to kind of defer to others on the panel to see if they have another point of view.
I think the new world is really festered with data, and I think AI and data science is the technology which harnesses that. So I think it just I would say commonsensical to believe that if every activity is now going to be data rich, and we have all believed in database decision making, so it's but natural that has to happen. I don't know whether there's any other way to look at it.
Okay,
sure. No,
I would, Samit, I would just add one line. I think coding is a broad term for the gentleman who's asking the question. If you just learn tools to pull data from your databases and learn Excel, I think in any job that's great. So whether it's SQL where your data sits, just learn SQL so that you can query the data, summarize it, put in an Excel file. Then you're not dependent on an analyst for your own success.
And preferably not something like NoSQL as the joke goes. So I mean,
yes,
good.
Sure. Thank you so Thank you so much, everyone. Thank you, Samran. Thank you, Pankaj, Abhishek, and Shweta. It was really insightful. I think I can see it in the comment section as well. Very insightful panelists and panel discussion. Any more questions? You can reach the team audience. So we're going to make sure that these members answer it for you. And thank you so much. So you already know how to applaud. So I don't have to say that one at the bottom of the screen. Thank you so much, everyone. So we're going to be back with the next session in a minute. Not more than that. Thank you so much.
Thanks a lot. Thanks everyone. It was real fun. Thank you.
Sure.